Today, however, I have my colleague Ilkka Hyvönen, who also delivered one of our first sessions and kind of kicked off this journey. We are happy to welcome Ilkka back. Once again, please note that all of the content in this session is available on our Skills for Jobs website. And you can also earn ECTS, so you can earn your credits if you register. So you can log into Educamu and enroll as a student if you're studying in any university, and then your credits will appear in your study path or opintopolku. So we have now many different micro degrees in Skills for Jobs. We've already completed practical AI. We are now going to complete the cybersecurity micro degree in the next month. And then we will be launching the Power Platform micro degree and the AI developer micro degree. But there's also a new degree called, which is to do with the data center. So please do check it out. These sessions are more of learning circles, so it's so much important that you also get kind of the expert insight. So Ilkka has been working in this area, so these are not like kind of teaching sessions, but sessions where our experts can basically share their insights, what has been important for them, what are the key topics that you should focus on, and what is expected is that you go through the material either before or after the session so that you can then correlate with what has been covered in this session. So with that, I will be sharing, of course, the links of Educamu and Skills for Jobs. But yeah, with that, I give it to Ilkka to talk about Azure security technologies. Take it away.
Mm-hmm. Thank you. So Ilkka Hyvönen, I'm a cloud solution architect at Microsoft. So I work with customers on Azure security technologies and products such as Sentinel and Defender. And today we are going to go through some of the key technologies, and I will share my screen and present something. So I'm not sharing the portal this time, and I will try to have time for some demos as well, so that you can see in concrete how do the products look like and so on, how to use those. Let me start sharing my screen. Yeah, so first I'll go through an overview about the Azure security technologies, and then we can discuss identities and access, and then application and data security. And the biggest part is platform security, so that includes things like network security and cloud security posture management and security information and event management. But first, I would like to explain a bit about cloud infrastructure attacks, because cloud security is partially same as any cybersecurity, but it also has some like specific characteristics. And one important point to understand is that there can be different ways how your environment can be exposed to any sort of outside attackers or threat agents. So usually you have some sort of exposure. So that could be, for example, insecure configuration, like open network ports or something like that, or vulnerabilities. So you might have some software running in your environment that has some known vulnerabilities, or it could be, for example, compromised user, which is a very common type of entry point when, for example, somebody is clicking on a malicious link in an email, and then their credentials are basically stolen, and then somebody else will log in with those. But anyways, usually after an exposure happens access. So somebody is maliciously trying to access your environment, and that could be, of course, in a different way. So they could access virtual machines, but in cloud environments, you also have these cloud native solutions, like in Azure, for example, you have app service environments, which are sort of platform as a service solutions for running your web applications or data stores. You have different types of databases, for example, SQL managed instances and so on, or IoT devices, for example. And when an attacker has been accessing your environment, usually their end goal is not the actual place they are trying to access. Usually they are interested in something very specific, like some sort of valuable information. So usually they have to do this lateral movement. So they first, for example, access one virtual machine that has one of these exposures that are listed, for example, and through that virtual machines, they usually are able to laterally move to other resources, like other virtual machines or data stores, for example. Data stores could contain something sensitive, like business data, for example. And eventually there's the actions. So data loss, for example, somebody could maliciously delete some data that could, of course, result in quite serious consequences, or data exfiltration. So it, for example, if you have some intellectual property, then somebody could try to extract that information. And ransomware, of course, is when somebody is encrypting your business data, and then basically you have to pay ransom to be able to access that data. Or resource abuse would be when somebody is, for example, doing crypto mining on your virtual machines, because that, of course, brings them some maybe bitcoins, but the amount of resources or costs they will create will be much more than what they will actually gain. But this is also quite typical in some cloud environments, typical type of action. So basically, this picture describes different possible scenarios, and from this we can basically understand that you also have then many type of things to consider. So you have to secure all these cloud native services and virtual machines and networks and so on. So that's why we need different solutions to protect and detect any sort of attacks. And this slide describes different categories of security technologies we have in Azure. So, for example, Identity and Access. Then we have this Azure AD, or Entra ID, as it's known nowadays. And we have these role-based access controls, so we can manage permissions of the users who are accessing Azure. And security posture management, which is basically identifying any misconfigurations or vulnerabilities in your environment. It could be any type of resources like virtual machines or databases, for example. So identifying, for example, if your database has it's not encrypted, or if it's somehow accessible from the public internet, for example. And threat protection capabilities, so that is basically detecting different type of malicious behavior and trying to protect from those. So there we have, for example, the CM and SOAR, and our product for that is Sentinel. And then, for example, external attack surface management is looking at the environment from an outsider's view, basically. And then apps and data security, so that has many fundamental security capabilities, so encryption in databases, for example, or disk encryption for virtual machines, and auditing, for example. So we have to, of course, have audit logs about the things that are happening in our environment, so that we can also detect any sort of malicious behavior. And then network security. So there we have, for example, DDoS protection, network segmentation, and well, firewall is not specifically listed here, but I would say that that falls into this category basically. And then on this slide, there are different product names for the solutions. So I will go through from these ones the most important ones for this category. But yeah, there are multiple solutions for different security capabilities, so identities, so Entra ID, and so on, and protect any sort of protections against threats or vulnerabilities and detections, and also recovery is important point. So for example, having backups or blueprints so that you can recreate your environment if something happens and so on. So that's also important. Then if we start with identities and access, so Entra ID, as it's called nowadays, so the name changed about a year ago. So the material in the course portal still refers to Azure AD. So that is our cloud-native identity and access management solution. And it might be confusing because our on-prem user directory is called Active Directory, and this Azure Active Directory was the old name, but this new Entra ID name is maybe a bit more distinguished from the old Active Directory. But basically, Entra ID is the place where you store all your user identities, so that they could be, for example, employees, they could be business partners like subcontractors, and also customers. So customers could be, citizens or any sort of consumers, for example. And then in addition to the user identities, you manage permissions to different applications, and you have capabilities like single sign-on to different applications. So those could be Salesforce or ServiceNow or your company own business applications or cloud-hosted apps, for example, and also on-prem apps. So you can also provision any permissions to these users to the on-prem apps. And well, you can directly create users here in Entra ID, but usually most companies, at least, or bigger organizations they have some sort of automation how they create users. So they could synchronize users from their on-prem Active Directory, or they could have these human resources systems like SuccessFactors, and have the sort of user feed when a new employee is coming into the organization. You have sort of feed of those users, and then you automatically create this identity and Entra ID in that scenario. And then in Entra ID, you can then define permissions to different applications. So who is basically able to access what sort of applications and so on. And one important thing related to Entra ID is, of course, managing those users. So when the user is created, then you still have to provision different permissions. So what kind of permissions the user will have, so what kind of business applications they can access. And also usually that is, of course, something that is changing all the time, because employees, for example, they get new roles or tasks that they are doing, so we have to manage those permissions. So there needs to be ways for them to request new permissions or automatically provide those permissions that they need. And then, of course, when we are managing user identities and access, one important topic is the authentication method. So the users need to be able to prove who they are. So we have different authentication methods. For example, this Microsoft Authenticator app is one method. And then we have, for example, Windows Hello technology. So that could be device-based authentication. If you are using a laptop that supports that capabilities, then you are able to identify, for example, with your face recognition or fingerprint, for example. Or you have these security keys, these like usually use USB devices that you are able to use for strong authentication. And one quite important topic related to Entra ID is this adaptive access, or the technology is called conditional access. So that allows us to define these flexible policies. So of course, organizations have different type of applications and they have different level of risk. And at the same time, users might be logging in from different devices, so they might be able to access some applications from non-managed devices like their home laptop, for example, or iPad. But usually the most critical applications you can only access from your work laptops or work mobile phones. And then we can define these different policies for different applications and use these different signals to decide whether the users can access those applications. And we can, for example, require this multi-factor authentication in certain scenarios if there is like a higher level of risk. So let's say that I log in from Espoo usually like Monday to Friday, but then once I try to log in from some other country in a very different pattern, like 3 a.m. from other side of the world, so that could be considered like a non-typical behavior, and then we could flag that as a sign-in risk. And in that scenario, we could require this strong authentication, for example, to verify that the user is who they are claiming to be. And of course, it might be a valid scenario, but if it's not, then usually the other person who is trying to log in on behalf of them, they hopefully don't have access to the multi-factor authentication methods. So if they are not a valid user, then they probably cannot use this MFA. Anyways, those conditional access policies are quite important, I would say, important concept. And I can maybe show the Entra ID portal here briefly. So this is part of Azure, and this is just a demo environment, but this shows basically the Entra ID tenant. So tenant is like the organization's own sort of instance of this Entra ID. Of course, some organizations might have more than one of those for different purposes, but usually most have one only. And I can, for example, view the users in this tenant. And there's a long list of users here, of course, and I could, of course, create new users or invite external users if I want to, for example, invite a business partner to access this environment. And then I, of course, have other capabilities here. So, for example, in Enter Connect, I have these capabilities for synchronizing and provisioning users from different data sources, for example. So basically, I could provision my users from human resources systems directly when a new employee appears, and I can also provision users to other applications, because some of the permissions are not managed in Enter ID, but they might be managed in Salesforce, for example. And then in identity governance, I have different, like this identity lifecycle features. So I can, for example, configure when user is changing the role, that's how to maybe remove some of the permissions from them and provision some new permissions. Moving on, I would suggest that we continue with application and data security. And well, this sort of continues with the identity and access management topic, but this is about Azure role-based access control, because Enter ID can manage also other applications access, but Azure has its own role-based access controls, and those are for the administrative users that will use the Azure portal, and of course these technical users. So, for example, service principals and managed identities are usually they are maybe applications or some sort of processes that also need to have permissions in the same way as human users need to have permissions, because they are maybe running some processes that of course need to access different data sources and execute with certain permissions. And these managed identities are preferred compared to service principal, because in a way you don't have to manage the secrets in these managed identities, because the problem is that the service principals have in certain ways similar username and password as regular users does, but the challenge is of course that you would maybe need to change the password once in a while, or the secrets that those technical user accounts have. But in managed identities, you don't need to do that, for example. In addition to the different type of principals or users and groups that you have, then we have these different roles. So Azure has these built-in roles, so owner, contributor, and reader level roles, and that could be assigned to subscription level, for example, or a resource group level, or individual resources like virtual machines. And basically, owner has the highest permissions on that scope, and contributor has like read and write level role permissions, but they don't have the capability to grant permissions to others. And readers, of course, then have only read level permissions on that scope. And then we also have these different roles for certain scenarios, like security reader that can access certain security related data on different Azure services. Like, for example, see incidents in Sentinel and so on. And like I mentioned, you have these scopes, so you can assign these permissions on a different scope. For example, if I assign contributor level rights to a resource group, those permissions are then inherited by the virtual machines and databases in that resource group. So that way you can sort of give development teams, for example, enough permissions to work within that area, but then you have, for example, other resource groups or subscriptions, and they would have no access to those resources. And next one is encryption. So I think that's important to remember that Azure has this built-in encryption capabilities, so at rest encryption. So we have encryption on virtual machine disks, and of course, anything that is physically stored in the hard disks or SSDs, for example, are always encrypted, but also the customers have their capability to have their own encryption on top of the physical level encryption. And then other storage services like blob storage and databases also have their encryption capabilities. And then encryption in transit, so encryption on different network connections that is also supported. And encryption in use, we have these confidential compute services. So that is basically when we're able to encrypt data even when it's processed within a virtual machine or a container. And an important topic related to encryption. So when we have these different encryption methods and we have these different algorithms that we use, is the encryption key management. So customers have either optional, well, in most services they have option either to use the platform managed key, which of course is easier to use because Microsoft is managing the encryption keys. But customers can also use these customer managed keys in many services, for example, in disk storage and so on. But of course, then they are completely responsible for managing those keys. So they need to consider things like when do we change the keys? So rotate the keys, because usually you don't want to have an encryption key that is valid for 5 years, but more like 3 months. So we have to rotate the keys every couple of months. And what if we lost the key? Because basically, if you lose the key, it's impossible to actually access the information anymore. But those are some of the options and considerations that customers can have. Yeah, so this slide sort of describes a couple of different scenarios in encryption scenarios for data at rest. So when we are storing data into different services. So first is the Azure platform native encryption. So when you are actually storing something on the disk. So when we are, for example, storing something physically on any of our data centers globally, if somebody would be able to steal the disks, which is very unlikely because of all the physical protections, that data would be already encrypted and it would be very hard to actually do anything with it without the encryption keys that Microsoft is managing. And then there's this encryption with customer managed key. So customer is storing the key in Azure Key Vault, which is the key management service in Azure. Customers can store data that is encrypted with keys that they only have access to. And some services also support this double encryption. I think that is probably included in the course material, so you can read in more detail that how it works. It's a bit complex scenario. At least you can find the information publicly in the internet in our portals if you want to read more. And then the fourth scenario is client-side encryption. So customers could also encrypt data in a database, for example, before it enters Azure. So there are different scenarios where you can, or how you can use encryption based on the business requirements and so on. But basically, this Azure Key Vault, so this is an Azure native service that has these REST APIs that the business applications or services can directly call and ask for the keys. And you can basically manage which resources can manage, which resources can access those keys. So I can, for example, scope an encryption key to a specific database so that only that database can access that key from Key Vault, and not even any humans, even like the highest level admins, can see that key. So that's basically that improves security, because then nobody's able to access the data in that database because they don't have that key. Only the application can access that and query that information. And then moving on, if we continue with the platform security capabilities, this is the longest section here. So we can start with Azure Network Security. So this Azure Network Security is following the zero trust approach. So for example, using the least privilege method. So the networks can be segmented to prevent lateral movement, that I explained in the beginning. So we can have these fine-grained permissions for different networks. So in Azure, you have these VNets or virtual networks, and then under those VNets, you have these subnets, and you can define on quite high range level that which applications or which IP addresses can access those other network segments to prevent any sort of lateral movements. So that can, of course, limit if somebody is able to get into your environment, then what they are able to see or what they are able to access, because everything is sort of segmented to prevent any sort of lateral movement or data exfiltration. And then we have these different protection capabilities that I will explain more about those, so protecting from DDoS attacks and other vulnerabilities. And then there's, of course, these encryption capabilities. So all the internal network connections and external network connections can be encrypted to ensure that nobody can then eavesdrop any of those connections. And this slide gives an overview of different network protection technologies. So DDoS protection is basically protecting your environment from a distributed denial of service attacks. So those could be volumetric attacks, for example, when somebody is directing high volumes of network traffic in your environment. They are trying to take your application down, and I think well, those are quite common nowadays, and even in the evening news, you read that some of the Finnish customers or public services organizations have been targeted with these different DDoS attacks time to time. And then we have these web application firewalls. So that is protecting applications from web application attacks and vulnerabilities. So things like SQL injections when somebody is trying to send SQL commands from outside the network, for example, try to exfiltrate something from an SQL database or modify some information in that database or cross-site scripting vulnerabilities. So this web application firewall protects from those sort of higher level attacks when they are trying to do some injection attacks or something like that. And Azure firewall, so that is more like traditional firewall in the sense that it's working in the lower layers of networks. So it can, for example, block malicious network traffic patterns and then also use threat intelligence. So Microsoft has this list of malicious IP addresses and domain names. So we can, for example, alert if there are some connections from those known bad actors, and you can then block those network connections. And you can also use this firewall for outbound network connections. So prevent any connections from your network to other networks. So to prevent any data exfiltration if somebody is trying to get some information out from your network to somewhere else. And then we have these network security groups. So I mentioned these VNets and subnets, which are sort of like logical software-based containers for different network resources. So they have these IP addresses, and you can then assign, for example, virtual machines into those subnets, and then you can route network traffic and have those network capabilities for the resources that they need. But these network security groups are then assigned to these subnets and virtual machines. So you can filter network traffic inside the virtual networks with these network security groups when those are assigned to subnets. So basically they contain rules, quite simple rules like allow connections from this IP address to these specific IP addresses and ports. So that is like called like stateless firewall in a way. And you can of course use this also for outbound network connections. So the network security groups can be used to filter traffic in the subnets and for virtual machines. So you are able to do that filtering on both levels. And usually you would have this Azure firewall in your sort of network boundary when you have external connections entering your network. These network security groups are more like in the internal network structure to implement the segmentation for the networks to prevent any lateral movement. So you can, for example, configure which virtual machines can access which resources and so on. And well, this VNet integration, well, this is also quite a complex topic, but maybe it's good to remember these private link and private endpoints and service endpoints that you are able to use these private endpoints, for example, to ensure that the network traffic from your resources to other Azure resources is routed from private networks, so it's not routed from the public internet. And I can briefly explain the different capabilities. So this Azure DDoS protection standard. So this is basically a global service that can protect from the denial of service attacks, and it has this adaptive tuning, so it's able to identify what is normal traffic volumes, and then anything going over that can be blocked if it doesn't fit the traffic pattern. But usually the customers have this central VNet, also known as hub, and usually traffic from public internet is entering through that hub VNet, and then you have these different capabilities like DDoS on the front, and then firewall and web application firewall in that hub. And then you have these other VNets called spokes, and your business applications or virtual machines would be on those spoke VNets. And then you have this usually VNet peering, so that those VNets are able to talk to each other, and traffic is allowed but segmented between those different VNets. And yeah, this Azure firewall, then it's this firewall, basic firewall capability. So it's able to filter networks and application traffic based on different signatures, and then we can use this threat intelligence, like information about known malicious IP addresses, to block some traffic, because Microsoft is collecting this threat intelligence from our own services that we provide to our customers and consumers like Xbox and Microsoft 365, because we are offering those services to globally all the customers, then we also are one quite big target for any DDoS attacks and other type of attacks. So we are able to collect that information, that what are the malicious actors, and then we can also help our customers with that information. And this web application firewall, so it's protecting the business applications from any sort of injection attacks and others. So you might have heard about this OWASP top 10 vulnerabilities for web applications. So in this web application firewall, we have these rule sets that will protect the applications against these top 10 categories of attacks, and also there's rule sets for managing any sort of bot attacks, so automated attacks against applications. So we are able to detect those common behaviors used by these bot managers. And you can also customize these rule sets. So if you have specific applications or requirements, you are able to build your own rule sets that basically define what is the allowed traffic patterns and what are the denied traffic. From network security, we could move to Defender for Cloud. So Defender for Cloud is our cloud-native cloud security posture management and workload protection platform. So the cloud security posture management is basically ensuring that you can securely configure your resources, and also, for example, manage the compliance requirement by making sure that the configuration is meeting the compliance standards that you have or you need to follow. Whereas this workload protection, it's about alerting, so detecting any malicious behavior against your virtual machines, databases, Key Vault, for example. So identifying identifying any malicious behavior and raising alerts based on those. And in addition to Azure, we also support AWS and Google Cloud. So you are able to get, for example, these recommendations for AWS in addition to Azure, and also Google Cloud is supported. And we are able to also protect virtual machines in AWS, Google Cloud, and on-prem environments as well. So we have different type of protections and detections for different products. So virtual machines, for example, containers, databases and storage services. Service layer is also very important. And then these specific Azure and on-prem services are also supported. So this cloud security posture management, it's about getting insights and visibility into your security state in your different environments. And then, of course, when you have identified what is the current situation, then you are able to address those findings. And I could again show some examples from my environment. So this is how the Defender for Cloud looks like in the environment. So in this overview page, I can click security posture so that I can see some recommendations how the environment looks like. So I have 5 critical recommendations and 12 attack paths, and my total secure score is 48%, whereas 100% is that everything would be perfect. And I also have these AWS environments connected, which is in very bad state. And I could click here to view recommendations, so I would see the recommendations for that specific environment. And in the recommendations, I can see which resources are affected. So, for example, I'm getting recommendations that for this AWS account, I have not enabled multi-factor authentication for this root account, which is in AWS very high level account that has a lot of permissions. So it's quite critical to protect that identity. And in this attack path analysis, I can get like a list of serious issues or combinations of different issues, because usually it's not that one single misconfiguration or vulnerability is such an issue, but when we have, for example, combination of different issues, then those become quite critical, because to be able to laterally move the attacker will usually need some sort of path or some sort of sequence of misconfigurations to be able to laterally move. So, for example, this shows a visual representation how we have a list of misconfigurations, whereas how potentially somebody would be able to access our key vault, and then through there they would be able to access some of my secrets or keys in that key vault. And then in workload protection, so I have different capabilities for protecting these resources, and I can raise alerts on different malicious behaviors. So I can see how there are different Azure services that are supported, and I also have a list of some alerts that have been raised on some of my resources, and I could click those and see that for example, I have some DDoS attacks in this test environment that are classified as high severity, and for example, exposed Kubernetes dashboard detected. So this way I can show that if there's some malicious behavior in my environment, I can get alerts from these scenarios. And all these detections are built in, so I don't have to sort of collect logs or implement any sort of logic how to be able to detect these misbehaviors, but I can automatically get these alerts if I have enabled this service. And so you have these different workload protections. So servers are one example. So this is basically endpoint detection and response and anti-malware solution. So that is able to raise those alerts from virtual machines, but we also have these capabilities for containers, for example. So we can see any runtime containers and raise alerts if there's some connections from known malicious IP addresses, for example, and we can also get recommendations about how we could improve the security of those containers. If there are any known vulnerable applications, we get recommendations how so that we should update those applications and how we could better configure the container environment to be able to make sure that it's secure. And finally, we also already mentioned about alerts. So it's important to also tie this to Sentinel. So Sentinel is Microsoft's security information event management solution, and it's also SOAR, so security orchestration and automated response. So basically that is a place where we can see the whole organization's security situation. We can collect data from different sources. Defender would be one place, but we can also collect log data, and we can raise alerts for any sort of malicious behavior. We can respond to any attack and investigate. So usually customers will use Defender and Sentinel both. So Defender would be only one data source for Sentinel. So they would integrate those alerts from Defender to Sentinel, and they would also collect log data from virtual machines, some business applications, for example. And in Sentinel, they can basically implement their own detections to define what is sort of normal behavior. They can use these alerts from different solutions like firewalls, for example. And that would be the single place where they can investigate any security incident happening in the environment. They can, for example, correlate data from different data sources, and they can respond either manually or automatically. So they can have these something called automation rules and playbooks to automate different behaviors. And basically, it's a centralized place where you can collect log data and other signals and monitor your security and detect any sort of incidents. And with this SOAR, you can then, for example, automate some repetitive tasks. So, for example, in the log data, if I get alerts, I usually have maybe IP addresses. And if I want to check the reputation of those IP addresses, instead of manually looking for that information, I could automatically enrich these incidents by using these playbooks and other capabilities. So usually these security analysts have they can have quite hard time managing all the incidents, and the volume of incidents can be sometimes quite high. So it's very important to be able to automate different things there. So this Sentinel is another service here in Azure, and this has its own area for incidents. So I should have these Defender alerts also here, but we also have many other data sources here. So I am able to connect different data sources, and I can even do custom connectors if I want. But many of the common security solutions are available here as built-in data connectors. So, for example, AWS, most common firewalls, all the Microsoft security solutions, and many others. And I can also access this threat intelligence, so I can integrate my own solutions because there are many providers in the market. I can even manually add threat intelligence here. And basically I can add any sort of IP addresses, file hashes, domain names, and so on here, and then correlate, try to look for that information in my incidents. And this slide just describes how Sentinel is like the single place where you can monitor your organization, whereas Defender Cloud and 365 Defender provide they will be one data source for Sentinel, but Sentinel can also have these other data sources. But finally, before we wrap up, I wanted to mention this Copilot for security. It's not in the course material, but you might have heard it. It is quite new solution. So this Copilot for security is our AI-based solution to help the security analyst, for example. So the idea is again to so that people don't need to spend that much time on these repetitive tasks, and we can also accelerate how quickly the security analyst can respond to different incidents, and the security analyst could more easily get context of these incidents to understand more about the situation, and also how we can help these more junior analysts to perform more advanced tasks, because that is also important how they can effectively perform these investigations and so on. So just brief explanations about the Copilot for security capabilities, so we can use it with many of these other Microsoft security solutions. For example, this Sentinel has this Koodaa query language, so you are able to look for these log files and look for specific information included in those logs. But this Koodaa query language, of course, has quite high learning curve. So instead of me having to learn how to write those queries, I can use natural language like English to write what sort of information I want to see. And then this Copilot for security can give me the actual query. So it can really help the more junior analysts, and in a situation where it's important to be very quick when you are investigating an incident, it can be really helpful. All right, but we are on top of the hour, but I think I have gone through all the materials I had today, but if somebody wants to ask any questions, I can be here for a couple of more minutes.
I would like to ask about the Copilot.
Mm-hmm.
Is
Sure.
it how widely is it used already? Is it kind of like a standard already in the companies?
Well, we have quite many customers already who are using it, but it's quite new solution, and I would say that many customers are still learning how to get the best out of it. So I would say that it's becoming more and more common, but it hasn't been there available for the general public for that many months yet. So I would say that we have quite many customers, but we are getting more and more all the time.
So it's definitely a technology we should pay more attention to as well as employees.
Yeah, I
Thank
would
you.
say that AI is going to be part of everyone's tool set in the future, definitely. All right, if there are no other questions, then I think we can close this one and I will stop the recording then. And thank you for everyone who participated.